Okay, so now we'll move on to the last part of our lesson, comparing data. Okay, so they say when comparing data sets, you can comment on a measure of location or a measure of spread. Okay, so basically comparing data sets means they will give you at least two data sets, at least two. And then what you need to do is you need to compare the two data sets either by using the measures of location. So measures of location is mean, median, so those kinds of mode, those kinds of things. And measures of spread are what? Measures of spread is you have interquartile range, interpercentile range, standard deviation. Those are measures of spread. So either when you're comparing data, it has to go either by completely by measures of location you compare, or if not, you completely you can comment on the measures of spread. That's how comparisons are done. Okay. All right. So then they say here, you can compare data by using mean and standard deviation by using the median and interquartile range. Okay, if the data set contains extreme values, then the median and interquartile range are more appropriate statistics to use. Okay, so they are saying here, I hope you guys can see this. You can compare data by using mean. So mean is a measure of location and standard deviation. So if you are using mean for the measure of location, for the measure of spread, you can use standard deviation, or by using median and interquartile range. Okay. So they say if the data set contains extreme values, I think you remember when there are extreme values, this was done in chapter 2, right? So in the event of an extreme value, you remember mean is affected. Do you recall? Mean is affected in the event of an extreme value. So if there are extreme values, then you should go with the median. Can you see? They say if the data set contains extreme values, for comparison, you should use median and interquartile range. Okay, better to go with median and interquartile range are more appropriate statistics. Okay, in the event of extreme values, mean will be affected, even the standard deviation. So better to go with median and interquartile range. Okay, and they say do not use median with the standard deviation or the mean with the interquartile range. Can you see? So you shouldn't mix it. Now they are saying when you're comparing data, there is a norm to do it. Okay, so you compare the measure of location. So I'll just highlight it again. Measure of location, if you are using mean, or measure of spread, you should use standard deviation. That's what they're saying. This is how the pair goes. Mean with standard deviation. Or if you're going with median, median should go with interquartile range. Okay, so they are saying, asking you not to compare it the other way. Do not use median. So if you take median for measure of location, don't use standard deviation with it. And if you are using mean, don't use mean with interquartile range. Okay, so make sure you keep this in mind, and when you're comparing data, use the correct notations. Okay, so let's move on to the question and let's practice with this. Okay, so let's practice now with exercise 3F. The box plot below shows the distribution of speeds of cars on two motorways. Compare the distribution of the speeds on the two motorways. Okay, so your task is to compare. So you will compare by commenting on what? When comparing data sets, we comment on the measure of location and we comment on the measure of spread. That's how the comparison should be done. Okay, so in this case, so measure of location, either you use mean, and measure of spread, you go standard deviation, or for measure of location, we use median, and for measure of spread, we use interquartile range. So in this case, you need to decide what is the most appropriate. Are we going to go with mean and standard deviation comparison, or are we going to go with median and interquartile range comparison? So I think you can see here that obviously when you take a box plot, it's very easy to immediately see the median, right? So median is the line that you draw in the middle. So this is the median. So easily we can get the median, and interquartile range is Q3 minus Q1. So you know in the box plot, the place where the box starts is Q1 and the box ending is Q3. So it's very easy in this case to compare the median with the interquartile. So what we'll do is first let's write down all the values. Okay, so motorway A, let's get the median. What's the median in motorway A? Median for motorway A. So that's going to be median is going to be 76, right? For motorway A, median is 76, and median for motorway B That's going to be 72, right? So from the data, we can see this is 72, median for motorway B, median for motorway A is 76. And also let's get the interquartile range. So interquartile range for motorway A, Q3 minus Q1, right? So taking motorway A, Q3 is 80 minus Q1. So Q1 is 75. So that gives me the answer 5. And interquartile range for motorway B. That's going to be Q3 minus Q1 for motorway B. Q3 is 75, right? This is the Q3. That's 75 minus Q1 is 65. So I think we can see here 75 minus 65, the interquartile range for motorway B is 10. Okay, so now let's go for the comparison. Okay, so now since we have calculated the median and the spread of speed, all we need to do now is to write the comparison. So we will be comparing measure of location using median, measure of spread using interquartile range. So what do you write here? So you can write here motorway A, right? You can see motorway A has a higher median speed. So motorway A has a higher median speed compared to motorway B. And the next one, so in the measure of spread. So measure of spread means it's interquartile range. So it shows how the speeds have spread, right? Basically, it shows the spread of the speed. So you can see when you compare the spreading, the spread of the speed, motorway A has a lower spread while motorway B has a higher spread. So you can write motorway B has a higher spread or has a greater spread. Has a greater spread of speed, right? So yeah, so it's a spread of speed. Spread of speeds. Motorway B has a greater spread of speeds compared to motorway A. Okay, so this is the comparison. As you can see, I have done the comparison by using two factors, using the measure of location and a measure of spread. Okay, so moving on to question number 2. They say two classes of primary school children complete a puzzle. Summary statistics for the times the children took in minutes are shown in the table. Okay, so class 2B and class 2F are the classes, and in class 2B, N means the number of children. There are 20, and there are 22 in class 2F. Sigma X means now here basically X is the time, right? The time the children took in minutes to complete. So sigma X means you add the times of all the children, the individual members. There are 20 members, so you add the times taken by all the 20 members, and it's 650. And 2F it's 590. Sigma X square means you know how X square statistic is taken, right? You take the individual time of each student, you square it, and you add it, right? So x1 square plus x2 square plus x3 square until there are 20 people means until x20 square. So you add all of it, okay? Right, so how do we get the mean? So let's take a class 2B. So in class 2B, I'll calculate the mean. Mean equals to sigma x over n. So sigma x is 650 divided by n is 20. And the answer is 32.5. Yeah, 32.5. So you can get the answer from the calculator. And then let's also calculate the standard deviation. Standard deviation calculation is sigma x square over n minus sigma x over n whole thing square. Sigma x square is 22,000 over n is 20 minus sigma x is 650 over n is 20 holding square. And you can type this in the cal and get the answer. So it's 6.614, 6.61437. Yeah, it goes on 8278. So basically, the answer correct to 3SF is 6.61, isn't it? 3SF, 6.61, corrected to 3SF. Okay, so I have the mean and standard deviation. Okay. Similarly, let's do the comparison for class 2F. So mean is sigma x over n. Sigma x is 598 over n is 22. So how much is that? 27 point, it goes on 181818. Yeah, so it's 27.2 basically. 27.2 correct to 3SF. All right, and the standard deviation, sigma x square over n minus sigma x over n holding square, square root. So sigma x square was 19,100 over n is 22 minus sigma x square is 19,100 over n is 22, right? Sorry, sigma x over n. I'm sorry, sigma x is not this. Sigma x is 598, right? Over 22 holding square. And then you type this holding in the cal, okay? You type the holding in the cal and get the square root, which is 11.27. Yeah, it goes on, right? 11.372360. Yeah, it goes on. So basically 11.4 correct to 3SF. Yeah, 11.4 correct to 3SF. Okay, so now we come to the comparison. Okay, so you have to compare the means and the standard deviations. Okay, let's compare now. All right, so now let's go for the comparison. So when you take the comparison, now just keep bear in mind what we are doing here. These are the summary statistics for the time that it took children to complete a puzzle, and these summary statistics are in minutes. Okay, so basically you can see the time taken. So class 2B has a mean time of 32.5 minutes, while class 2F has averagely a mean, the time taken to solve the puzzle is 27.2 minutes. So we can kind of see here that when you take the two classes, class 2F is generally fast, isn't it? Because they solve the puzzle in a less amount of time compared to class 2B, right? So you can give a general observation here. So you can say the mean of class 2B, the mean time taken by class 2B, right, is higher in comparison, to class 2F. And what does this mean? What does this mean? This means the children in class 2F solve the puzzle faster, isn't it? So this means thereby class 2F is generally faster, isn't it? Is generally faster in completing the puzzle. Okay, so that's the comment we can give regarding the measure of location. Also, let's give a comparison with the measure of spread. So measure of spread means how the times are spread, right? So you can see that the times are like basically standard deviation shows how much the data is spreading around the mean. Okay, so around the mean, you can see this has a lower spread. The times are low, having a less spread. But over here around the mean, there is a larger spread. So which means in class 2F, there is a higher spread of times. There is a higher spread of times than class 2B. Okay, so you can write standard deviation. Standard deviation, write the full word. Standard deviation of class 2F, right, is higher. Is higher than class 2B. So what does this mean? So this means what? The times in which means what? The times for class 2F, there is a larger spread of time, right? Which means thereby times in class 2F are more spread out. So some kind of a comparison like this. You just need to make some comparison to compare the measure of location, which is the mean, and the measure of spread, which is the standard deviation. Okay.